Okay, this is physics. Sorry, I'm trying to find my pen. There it is. This is physics, and we are moving into module 5, which begins on page 141 in your textbook. Okay, so module 5. And I want to remind you that even though I haven't maybe been as diligent with this as I had intended or hoped from the beginning of the year, you hopefully are keeping your 3-ring binder going, and you're having dividers for each module, and you're doing your notes and your OYOs and review questions and practice problems, experiments, and tests in that order for each of those modules, so you have them for reference, both as you continue this course and in the future. So hopefully you're doing that. If not, with module 5, start up again and keep that going. Okay, so I just want to talk about a few of the key points here at the beginning of module 5. What you're going to do for this first part of module 5 is read pages 141 through 145. Now, one of your responsibilities will be to do experiment 5.1, which is on the topic of inertia, and then you will have the OYOs 5.1 and 5.2 to answer, which appear on page 145. All right, so that's your responsibility. I'm not going to cover everything here. I just want to point out a few of the key points, right? So with this module, we could move into Newton's laws, and you may be familiar with Newton's laws. So you may have some familiarity with them as we move through this, but obviously we're going to look at these, or your text is going to ask you to look at these in more detail. If you have not read about Sir Isaac Newton, it's worth taking the time to find. You can just find a simple biography about him, preferably a Christian biography about him, because he was a devout Christian. And what's most interesting about Isaac Newton is that he is the father of what has become known as Newtonian physics, and it's kind of centered around these laws that he established. And in modern science, they love to talk about how, well, we've moved way past Isaac Newton, and yet it requires that these laws, his Newtonian laws, it's still necessary for these to be in place and followed in order to do things. So I find that pretty interesting that such is the case. That such is the case. So if you can find a good shortish biography, it's worth a read. Okay, but here is the key things. All right, so Newton's first law, which we look at here, is this: an object in motion, and it's worth taking the time to write this down and get it into your mind. An object in motion, and spell each word correctly as you do it, or at rest, not risk, or at rest, tends to stay in motion or at rest until it is acted upon by an outside force. And this is the key concept that you are. I can't spell. By an outside force is what I wanted to put there. This is the key concept that you are expected to come to understand in this first section here. That's it. That law. Okay. Now, our experience is that, especially like on a carpet, if you were to roll a ball, you expect it to stop, and it seems contrary to what this is saying, because it says, well, I started that ball in motion. Shouldn't it just keep going in motion? Well, the law says if it doesn't keep or stay in motion, that some outward force or outside force must have acted upon it, and that's the case of rolling the ball on the carpet. That would be friction. Okay. Now, this first law is the law of inertia. Okay, the law of inertia. And that's what your experiment 5.1 is going to demonstrate. Okay, and so you're going to want to read these pages carefully. And when you read up to the experiment, then do the experiment. I've given kind of an extra day for this section because there's an experiment within it, right? So when you get to the experiment, perform the experiment, note your observations, and then beginning on page 144, read following that experiment, because then you will read the author's explanation of things. And then on page 145, you have 5.1 and 5.2 that you want to answer the OYOs there, okay? But let me just read the paragraph right before experiment 5.1 on page 143, because I think the author makes an important point here. When students read the law of inertia, they tend to think, that makes sense. And then they move on. That's probably your reaction at this point. Okay, you might think, that makes sense, but so what? Well, it turns out that Newton's first law has many, many physical implications. To see one of these implications, perform the following experiment. Okay? So it turns out that in a simply stated truth, it addresses a multitude of circumstances, or as the author says, it has many implications, right? So that's why the author wants you to take time to really stop and think about this, and think about it through the experiment that he asks you to do. Okay? And I would encourage you, read up to that experiment, do the experiment, do it carefully, be observational in that experiment, and then read the text following that experiment. All right? The benefit of doing that is that you can do the experiment, develop your own thoughts and your own observations, and then read the author's comments in that regard. And you've already developed your own ideas based on that experiment. And when you do it that way, then you're going to be rewarded where your thinking falls in line with what the author says, and you're actually going to learn better where your thinking was off, and you compare that with what the author says. All right? So, real short video, just to introduce this first law, the law of inertia. And I would tell you, you need to memorize the title, the law itself, and the scientist's name who came up with the law, Sir Isaac Newton. All right? Okay, on to your assignment, the reading, the experiment, and then answering the OYOs.